2/3 C each year, and the last 10 years you pay C each year. So what's the reason why, why are we even interested in this kind of weird loan? So you stand at time zero, you really need $1,000 or kroner or whatever, so you borrow them here. And then what this contract says is during the next 10 years, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you will pay back an amount that each year is equal to 1/3 C. Whatever C is, we will determine C according to what makes sense in a second. So 1/3 C. And then the 10 years that come after that, you switch up the payment so that then you pay double the amount as you did the first 10 years. So 11, 12, 13, 14, 15, 16, 17, 18, and 19, 20. So then you pay 2/3 C. And one of the reasons why some people may choose this kind of loan, for example, if they're buying a house or something like that, well, think of it this way. Maybe you're a student. So the first years, you're living off SU or something like that. So you prefer to pay as little back as possible. And then here, you're probably a bit richer. And then here, you're probably even richer, so you're able to pay even more back. So for some people, this may occur because salary dependence, so you don't really have any other choice. And in other cases, it's just a case of speculation from the company. So yeah, 28, 29, 30. So in the last 10 years, you pay C. So like a rather big amount here. So here in the last 10 years, it's called C. C, C, C each year. And we have a yearly interest of 4%. And the first answer we want to answer is, what is C? Now, we can kind of expect that C is quite a lot, right? Like compared to if we had just tried to find another kind of C, like if we had tried to find some kind of average C for all the years instead, then that C would definitely be smaller than this C. But let's try to find out what C is here. Well, we stand at time zero, and our present value at time zero, our present value at time zero of above payment stream is equal to, well, what is it equal to? V of 0 is equal to, well, first we have 10 years payment of 1/3 C each. So that is 1/3 C multiplied by the initial present value of essentially an annuity in arrear. So just because this is a course in basics, we can also do the discounting here manually. So it's multiplied by, well, this amount is discounted 1 period, this amount is discounted 2 periods, the next is discounted 3 periods, up until the last one, which is discounted 10 periods. So this ranges for S equal to 1 all the way up to 10. Right? Actually, I should have written this in blue because I want this part to represent this part here. Okay, so let's continue on. Don't know where that color came from. What is the present time zero value of the 10 payments that are here? Well, what happens to this payment here? This payment of 2/3 C. Well, the first 2/3 C payment is discounted 11 years. The next one is discounted 1, 2, 3, 4, 5, 6, 12 years, and 3 years, and 13 years, and 14 years, etc., etc. So what we have in the next case is 2/3 C multiplied by V to the S for S equals 11 to 20. And that was the case for the next 10 years. And for the last 10 years, well, we just kind of do the same trick all over again. And that is, well, this one is discounted 21 years, and then the last one is discounted 30 years. So we have S equal to 21 up to 30 of discounting factor to the S multiplied by C on each term. And this is the one that corresponds to the last 10 years. Now, can we write this up a bit nicer without summation? So can we evaluate the sums? And the answer to that is, well, yes, we can. So first of all, we can notice we can take C out of all of this, and then we have some of this other stuff left inside. Another thing we can notice is this. Now, this is a rule that I would like you guys to remember, and that is I can always take something from the indices, I can subtract it from the indices, and then add it onto the index inside the sum. So just in general, if I have S is equal to A plus K to B plus K, then I can take this thing over here and I can remove the K and place it into the index that's inside the sum. So I can write it as V to the S plus K for S equals A to B. And one of the reasons why we want to do this is because then inside here I can have, well, a third multiplied by the sum for S from 1 to 10 of V to the S, and then plus 2/3. And what I want to do now is I want to take 10 away from this index and 10 away from this index, such that I have V to the S plus 10 inside here, and then outside my S just runs from 1 to 10. And then I have C, I have 1/3 C, 2/3 C here. So 1/3 C, 2/3 C, and then plus C multiplied by V to the S, and I will remove 20 from the index below and 20 from the index above. So it's S plus 20, and here I have S equal to 1 and S equal to 10. And when you think about it, there's really no difference because the first term here is still V to the 21st, as is the first term here, and so on and so on. But the reason why I want to do this is because now I can take V to the 10th outside of this sum and V to the 20th outside of this sum. So what I have now, sorry, I should not have written the C in here. This is kind of what happens when you just talk to yourself inside the screen. I already have the C outside of the parentheses, so everything is fine. Okay, so here I have equals C multiplied by, well, what do these three terms have in common? They have the sum of V to the S in common, right? Sum of V to the S for S ranging from 1 to 10. And inside the parenthesis, I have a third plus 2/3 multiplied by V to the 10th, and then plus 1 multiplied by V to the 20th. And now we have a formula for what the present value at time 0 is. But also, the present value at time 0 is equal to 1,000. So hence we can find a value for C. So hence C is equal to 1,000. So this whole thing here is equal to 1,000, which means that C is equal to 1,000 divided by this whole expression, divided by the sum of v to the s for s going from 1 to 10, then multiplied by 1/3 plus 2/3 times v to the 10th plus v to the 20th, like that. And let's try to take a look at what that gives us. Well, first of all, let's just recall that, in fact, this sum here evaluates to 1 minus v to the 10th divided by I, right? Because this is the present value of an annuity in arrear for 10 years, and that's given by this through the formula of geometric sums. You can also find this inside your notes.